Good morning, everyone. You should have completed the two questions that you see right here. One of these questions is talking about finding the area of a square. Remember, to find the area of a square, you just multiply the length times the width. And so your first answer, should have come out to be 71.2. And your second answer should have come out to be 26.95. And remember, when you're plugging these in, you're actually just doing 8.9 times 8. And then for this one, you're actually just doing 7 times 7.7, and you're dividing all of that by 2. Today, we're going to talk about chord properties and segment lengths in circles. So you should have received the notes for this, at least the notes page. Talks about 7.1 segments. And if you notice, it's set up into different sections. And we're going to go through the different sections, and you're going to be recording or taking down notes for each little part that go along with the section. The first section that we're going to talk about is if two chords are congruent, then their corresponding arcs are congruent. So on the first page, right above number 1, you should see that. Also notice that each question or each part has its own circle. Now, in each circle, it has a center, but please understand that in some of the drawings that you're going to do, you're not going to have the actual chord or tangent or secant is not going to go through the center of the circle. But what this means right here is that if I give you a circle, and within that circle, we have two chords. One chord here, one chord here. And I give you these tick marks. Then basically what we're saying is that if this is chord A, B, and this is chord C, D, and I tell you that these two chords are congruent to one another, that also means that arc AB is congruent to arc CD. Let's look at number 1. I'll give you a minute or so to copy number 1 down, and then we'll talk about how we can solve number 1. Okay, now if you notice in number 1, it tells us that we've got two chords that are in the circle. It also shows us that these two chords are congruent to one another because they have tick marks. And remember, in first semester, we said that these tick marks tell us when things are the same length. So since these chords are the same length, then that also means that these two arcs are the same length. And so therefore, that means that when things are congruent, the way to solve them is we set them equal to one another. And so notice when we set them equal to one another, we are going through and we're doing multi-step equations. So the first thing you would do is you would actually subtract 3x from both sides. Then you would add 7 to both sides. And you would end up with x is equal to 2. Let's move on to the next question, or the next one. Find the length of WX. I'll give you a chance to copy this one down, and then we'll discuss it. Now notice that with this particular problem, it doesn't just come out and tell us that these two chords are equal to each other. But what we have to understand is this. We see that right here we have two central angles. And remember what we said. We said that, well, if the angle is centralized, that means that the arc is congruent to it. Well, in this particular problem, these two angles are congruent because of the arc marks. So that means that these two arcs are congruent. And when we think back to what the rule said that if my chords are congruent, that means that my arcs are congruent. But it goes both ways. Well, if my arcs are congruent, that means that my chords are congruent. And so since my chords are congruent, I can do y plus 4 equals 2y minus 3. Once again, I'm looking at solving multi-step equation. I would actually subtract y from both sides to get this step. Then I would add 3 to both sides and I get y. But this is where students tend to make mistakes because they do not read the full question. The question says find the length of wx. Wx. So therefore, I will have to take my answer right here and I need to plug it back into my equation. And since we want to know the value of wx, then I plug it back into wx as 2 times 7 minus 3, and that gives us 11. And so wx is equal to 11. Here's number 3. As you're copying this down, number 3 should look familiar because it was actually one of the questions that was on your test. Well, it was very similar, I put it that way. Very similar to a question that was on your test. Now notice right here that this circle is cut into 3 different arcs. This arc right here, which is BC, this arc right here, which is AB, and this arc right here, which is CA. Well, I know what arc BC is, but I'm trying to figure out what these other 2 arcs are, and I know that these arcs are congruent to one another because we have these tick marks. And remember what the rules said. The rules said that if my chords are congruent, that means that their arcs are congruent. So I need to figure out, well, how much of this circle is left? Well, in order to figure that out, we do 360 minus 100. When I do 360 minus 100, that leaves me with 260. Since I have 260 degrees left, and we said that these 2 arcs are congruent to one another, which means that they are equal in size, then divide 260 by 2. When you divide 260 by 2, notice that leaves you with 130. Just to kind of refresh your memory or to review things that we talked about, see if you can determine what the value of this angle is, and then explain. Just something for you to think about. Now let's look at the next section. If 2 chords are congruent, then they are equidistant from the center. Well, remember, when we're talking about equidistant, equidistant means that they are the same distance. Equidistant means that they are the same distance. And ladies and gentlemen, please make sure you understand that these notes, these are your notes. This is nothing that you have to turn in. So whatever notes you need to add to these, please do so. If you didn't know what equidistant stand for or meant, then write same distance. That way you'll know when you look back at your notes. So let's look at number 4. Give you a chance to write that down, and then we'll discuss it. All right, so let's think about what we're saying right here. So what we're saying right here says in circle K, K is the midpoint of RE. And remember, since K is the midpoint of RE, that means that KR and KE are the same length. If TY, which is from here to here, represents this, negative 3x plus 56, and US represents 4x, then we need to find the length of TY. Well, remember what the rule said. The rule said that if two chords are congruent in size or in length, then they are equidistant from the center. Okay? And so what I can do right here is I can say negative 3x plus 56 equals 4x. Well, remember the next step right here says that we will add 3x to both sides. And then the last step says that we would divide by 7. And that's how we get x equals 8. But once again, remember, it's not asking us to find x. It's asking us to find the length of ty. So let's think about what we would do right here. Well, if ty is represented by negative 3x plus 56, well, think about it. What you would then need to do is you would need to say negative 3 times 8 plus 56. And, of course, we know that that will give you 32. Let's look at the next one. If a diameter is perpendicular to a chord, then it also bisects the chord. Remember, perpendicular means that something makes a 90-degree angle. All right? Perpendicular means that you make a 90-degree angle. It also bisects. Remember, bisects means to cut in half. Not just cut into two pieces. We cut it into two equal pieces. This results in congruent arcs too. Well, think back to what it was saying. Now, if you have this, then you're also saying that these arcs are congruent. And what you have to make sure you understand right here, ladies and gentlemen, is that if I tell you to if I tell you some certain steps, then you can go in reverse order and it still proves what you want. Sometimes this creates a right triangle and you'll use the Pythagorean theorem. And remember, the Pythagorean theorem says a squared plus b squared equals c squared. So I'll give you a chance to copy down number 5 and then we'll discuss it. All right, so let's look at this one. So what we're saying right here, we're saying that in circle Q, KL or arc KL and arc LZ are congruent. So these two are congruent. It says if CK is equal to 2x plus 3 and CZ is equal to 4x, find x. So remember what we said. If my arcs are congruent, that means that these two line segments right here must also be congruent. And so we can set them equal to each other. Remember, the next step would be to subtract 2x from both sides. And when you divide by, divide by 2, you get 1.5. Now we can stop for this one because it tells us that we need to find x. And just remember, just to go back with this, if we subtract 2x, then that means we end up with 3 is equal to 2x. And then remember, you're just dividing by 2, just to give you a refresher. Let's look at number 6. Give you a chance to copy that down, and then we'll solve it. Now, if you notice right here, it tells us that in circle P, PM and AT are perpendicular to one another. So if PM and AT are perpendicular, that must mean that this is where my 90-degree angle is located. Well, it also tells us that PT is 10. So that makes a 90-degree triangle or right triangle. Let me make that clear. But it also tells us that PT is equal to 10. So I can put 10 right there. And then it tells us that PM is equal to 8. So I can put an 8 right there. And let's think about it. Well, if this is a right triangle and I'm trying to find the leg, then I can use the Pythagorean theorem to set it up. Well, if we look at this, the next step would be to basically simplify the exponents. Subtract 64 from both sides. And then I need to take the square root of both sides. And once again, these are your notes. So in this particular step, if you need to write down square root, right, or take square root of both sides, then write it down. Because remember, these are here to help you. And when you take the square root of both sides, you get MT is equal to 6. But let's make sure we understand something. We said that if a diameter makes a perpendicular with a chord, it also bisects the chord. So therefore, we just found this part right here to be 6. Well, if this diameter bisected that chord, that means that if this is 6, that's 6. And so together, we end up getting AT to be 12. Let's look at number 7. All right, so let's look at this one. It says that find the length of CE. Well, let's make sure we understand some things. We should see right here that the length of BD is basically the length of this part plus that part. Well, if this part is 20 and that part is 5, that means that the length of BD is 25. Also, make sure you understand that BD is a radius. Well, not only is BD a radius, CB is also a radius. And if I wanted to, if I drew a line from here to E, BE will also be a radius. If that's just something if you wanted to add it in. Well, now we need to know what is the length of the radius. Well, if BD is a radius and it's 25, then that means that all the radius and plural form radii have to be 25. So if the radii or the radius BC is 25 and this side right here is 20, then think back to what we're doing. We're trying to find the length of this. And I set it up as so. And now we go through the orders of operations, meaning we have to get rid of exponents first, simplify exponents, so we end up with, finally, x is equal to 15. But if we go and just show, then that means that we had 400 plus x squared equals 625. And we subtract 400 from both sides, and we end up getting x squared is equal to 225. And once again, we take the square root, and we get x is equal to 15. But once again, it's also asking us to find the length of CE. So, and for the rule says that if we have a diameter, or in this case, a radius, if it creates a perpendicular with the chord, it also bisects the chord. So that means that if this right here comes out to be 15, then that means over here, this has to be 15. And so we can really just say we double it to get 30. Let's look at number 8. Give you a chance to copy it down, and then we'll solve it. Well, when I look at this problem, notice that MK is a radius, and the one thing we know about MK is that MK is split into two parts. One part is 36 meters and the other part is 14 meters. So that means that my radius is equal to 50 meters. Well, we said that if a radius or diameter creates a perpendicular with a chord, it also bisects the chord. Well, in this particular case, let's look at what we're doing. Well, if this little part right here is 14, and we just said that 36 plus 14 is 50 represents my radius, that means that even if I drew a line from K to L, that would be 50. And so now I'm looking to find x. So how can I set that up? I set it up as 14 squared plus x squared is equal to 50 squared. Then when I simplify the exponents and solve, I get x is equal to 48. Well, if x is equal to 48 right here, that means that when I double it, I should get 96. Now let's turn on the back. So now we're talking about segment lengths and circles. And there are three different things that we're going to talk about with segment lengths. One of them is when you have a secant and a tangent. Now let's make sure we review both of these. Remember that a secant intersects a circle twice. All right. So this would represent a secant because not only does it intersect the circle twice, but it actually goes outside of the circle. That's the reason why you see outside right here. But when we're talking about a tangent line, all right, a tangent line only, and this tangent is spelled incorrectly, should be tangent, not tangent. But this tangent line will only touch the circle in one place, and it'll only be outside of the circle. But what secant and tangent tells us is that they're meeting at an external point, meaning the vertex, the point of their intersection, is on the outside of the circle. We're also going to talk about chords and chords that intersect inside. Now, chords that intersect inside mean that they're inside of the circle, but please do not get this mixed up with angles on the inside of the circle. And then last but not least, we're going to talk about secants that intersect outside of the circle. So if you look right above number 9, 10, and 11, we've got two chords that intersect inside of the circle. So in the box located right above number 10, you should write down the formula part times part, or part A times part A, equals part B times part B. Because what that is saying is that I'm multiplying both parts of line A, no matter what they are, multiplying them together. We'll get to some examples. And I'm going to set that equal to both parts of line B, or chord B. So you can actually put part A and then part A and then part B and part B. Also, make sure you write that you go down the chord and multiply. So let's look at number 9, an example. So if I ask you to solve for x, remember right here, it's telling us that we multiply those two because they represent the same line. So I multiply them together. And then I multiply these two because they represent the same line. So when I set it up as 9 times 2 is equal to 6x. Please understand, ladies and gentlemen, that these two chords do not go through the center. Even though your circle has a center point, your chords do not have to go through them. So when we write it as 9 times 2 equals 6x, then remember 9 times 2 is 18. And then when I divide both sides by 6, I end up getting x is equal to 3. Let's look at number 10. I'll give you a chance to copy that down. As you're finishing up writing this down, please notice that these are not diameters. And remember, even if a diameter does intersect a chord, if the diameter does not create a perpendicular, then it does not bisect it. All right. Once again, if the diameter does not create a perpendicular, then it does not bisect it. And since AC is not a diameter, it doesn't bisect BD. But as I'm setting this up, look what we get. Well, when I set it up, I'm setting it up as part A times part A equal to part B times part B. That gives us 96 is equal to 6x squared. Because remember, when we are multiplying like variables, you add the exponents, and that's how we end up with x squared. The next thing we do is we divide both sides by 6, and you end up with 16 is equal to x squared. And just like in some previous problems, we need to take the square root of both sides, and we end up with x is equal to 4. But it does not ask us for the value of x. It wants to know the value of, or the length of dB. So I now have to take this answer and plug it into the problem. And for this one, I get 12. And for this one right here, I get 8. So therefore, the length of dB is 20. Now, I do want to caution everyone. Do not think that just because two chords intersect inside of the circle that they will always be the same length. It is just a coincidence that when I find the length of dB to be 20 and the length of AC to be 20, just a coincidence. All right, and I'm saying that, let me repeat it. Do not think that just because my two chords in this problem are the same length that it will always happen that way. Give you a chance to copy down number 11. Remember, I've been preaching to you all about making sure you understand the rule and trust the process. So even in this case right here, when I say understand the rule and trust the process, well, the rule for this is saying that I have two chords that intersect inside of the circle. And the process says that I am going to multiply part A times part A and part B times part B. Now we're back to basic algebra. I would actually do the distributive property right here. All right. And when I do the distributive property, what we're saying is that gives me 5x is equal to 10x minus 40. Well, I need to get like terms on the same side, so I will actually just subtract 10x from both sides. And I get negative 5x is equal to negative 40. But of course we know that when I divide both sides by negative 5, a negative divided by a negative gives me a positive 8. Well, now that it's asking us to find the length of AC and DB, now all I do is take my value of 8 and plug it back into the problem. And as I plug it back into the problem, I see that AC is 8 plus 5, which is 13. And as I plug it back into this problem, well, first I've got 8 minus 4, which is 4. And 4 plus 10 gives me 14. So therefore, AC is 13, DB is 14. Let's look at the next type. The next type says that if I have two secants that intersect outside of the circle, meaning that my two secants, they come to a vertex outside of my circle, then that means that the rule says that I'm going to take the length of the outside of one secant times the whole length of that same secant, and I'm going to set it equal to the outside of the second secant times the whole length of the second secant. Now, remember, and as you're writing this down, make sure you remember this right here. Sometimes you may have to add to get the whole. So if I look at number 12, give you a chance to copy that down and then we'll discuss it. Well, if you notice right here, think back to what we're saying. So the rule says that if I have two secants that meet at the vertex outside of the circle, then that means that I can take the outside times the whole length of one secant and equal that to the outside times the whole length of another secant. Well, the outside of this top secant times the whole length is 20. And then when I set that equal to, I do set it up using the same rule. I set it up saying that the outside of that secant, which is 4, is equal to the whole length of that secant, which is 4 plus x, or x plus 4. Now remember, we're saying the whole length. And when we're saying the whole length, we're talking about from the vertex all the way to this point right here. mixed up right there. Let's go, keep going. Talking about from here all the way to here. And so that entire length right there is 4 plus x, because I have to take this little length going from this vertex to the circle, and then I have to take from this part of the circle to the other part of the circle, and that's the reason why we add them together. Now I can't add them together and get 4x, so that's the reason why it has to be 4 plus x. And when I set it up as so. And so now we're moving on into doing orders of operations and basic algebra. So we end up with 140 is equal to 16 plus 4x. That's how we get 124 is equal to 4x, because we subtract 16 from both sides. Sorry. And when I divide by 4, I get 124. Divide by 4, excuse me, I get 31. Sorry. Let's look at the second one. So remember, as I'm setting this up, I set it up as 5 times x, 5 times x plus 5. Or we're using 6 right here. So it'll be 6 times 6 plus x equals 5 times 5 plus x. Because once again, I am taking the outside times the whole. The whole is this plus that. And then I'm doing the same thing for the other one. I'm taking the outside times this plus that. Now, I know some of you all may be saying, well, Ms. Collier, that's just 14. And you're right, it is 14. But notice that even if I leave it at 6 plus 8, there's nothing wrong with that. But up here, I can't say x plus 5 gives me 5x. No, it stays x plus 5. And so now when we look at orders of operations, we ended up simplifying this part over here and we get 84. Because I know that when I add 6 plus 8, I get 14. 14 times 6 is 84. But over here, I have to use the distributive property. And the distributive property says that I get 25 plus 5x. Now right here, I subtract 25 from both sides and I get 59 is equal to 5x. And when I plug that into my calculator, or when I solve that, I end up getting 11.8. Number 14, we're actually going to come back to a little bit later. I'll give you a chance to just copy it down. But that's something we'll discuss at a later time. But I'll give you a chance to copy it down. Feel free to see if you can solve it at some point. But we'll come back to that one later. I'll skip on through that one. Let's talk about the third type now. So the third type, which is type 2 with a twist, is where we have a secant and a tangent. Now, of course, we know that when we have a secant and a tangent, the rule says that we have to take the square of the tangent line. So we take whatever the length of the tangent line is and we square it. So under here, you may want to write tangent line and then put that in parentheses because we're squaring that. And we're setting that equal to the outside times the whole. So really, we're using part of the same rule that we just went over. But the reason we can't use all of that is because now we're dealing with a tangent and a secant. So let's look at number 15. Give you a chance to copy it down. So the rule says that if I have a tangent and a secant, all right, and one thing some of you all may want to do is start jotting down, like, what do you have? Well, right here, I have a tangent and I have a secant. Since I have a tangent and a secant, that means the rule says that I have to take the tangent squared, and remember, this right here represents my tangent. This 12 represents my outside, and the whole represents both of those things added up. So therefore, when I plug them into the formula or the rule says that I do 24 squared is equal to the outside, which is 12, times the whole, which is 12 plus x. Well, now I just go through orders of operations. So the next thing I do is I simplify and I get 576 is equal to 144 plus 12x because of distributive property. Then I subtract 144 from both sides and I get 432 is equal to 12x. And then I divide by 12 and I get x is equal to 36. Now remember, a way that you can check it is to take your answer, which in this case is 36, and plug it back into here. Plug it back into here to see if this side equals that side. Last but not least, you have number 16. Number 16, I'll give you a chance to copy that down. Once again, if you notice, we have a tan and a secant line. So since we have a tangent line and a secant line, then that means that I can use the rule tan squared is equal to outside times the whole. Well, we know that this represents my tangent, this represents my outside, and this right here represents my whole. So when I plug it in, look at what I get. Now, using orders of operations, I end up getting x squared equals 100. And when I take the square root of both sides, I end up getting x is equal to 10. So now, my teacher for the day, if there's any part of this that my students did not get, please feel free to go to the board, to the screen, and you can rewind back to any part so that they can get it. Students, please be advised that you will be receiving some assignments on this. So please make sure you do your best effort, do your best work, and put forth your best effort. And I look forward to working with you all next time.